Hey, this is Dr. Tony Gannon, and I'm going to go over the physics of the swing using the forces of nature, using the ground forces, using equal and opposite reactions to maximize the power behind the swing. In order to jump as high as possible, you have to apply a great force into the earth, and the earth applies a equal and opposite force that allows you to spring up. In nature, we have these equal and opposite reactions, and that's Newton's third law. And essentially, what that means is in order to maximize pushing something, you coil this way to push this way. Okay, and that's exactly what's happening at the swing. Balls coming this way, bats coming this way. They're going in equal and opposite reactions at the moment of contact. And the harder you are, the harder the ball's coming, the harder the contact's going to be at the same time. So that goes this way. And we know this because if you want to hit a ball out of the park and somebody's throwing 30 miles an hour versus somebody throwing 100 miles an hour, you'll know that that collision will go farther if you can hit that 100-mile-an-hour pitch, because it's an equal and opposite reaction, meaning that the faster it's coming, the faster it's going, right? And so the harder you spring down, the harder you jump up, and the harder you coil, the faster you'll recoil this way. So essentially, he's using these laws of physics to put an application of force into his hip and into the ground simultaneously. Now we know that he's loading the hip because I don't see that this knee is beyond the toes. And in fact, what he's doing in loading the hip is he is contracting the glute muscles, which allow for external rotation, which means that this cheek on this side is going to rotate a little more towards the third base dugout so that it can internally rotate in the moment. So we're applying a force into the ground so that we can push up. We are rotating the pelvis so we can rotate this way. And he's preparing his body for these sequences. And I'm not sure who's taught him this, but apparently this swing is something he's kept all the way from high school. So he's in touch with his body enough to know how to maximize these forces. He's applying a force to the ground via his body weight on the backside of his body, going through the hip and loading his glute muscle. And if he feels tension anywhere, it's going to be in the butt and the hamstrings, less so the quads. So he's loading up that backside so that he can recoil. He's coiling to uncoil this way. Now, as the swing begins to happen, he's applying that force even more so into that hip. So you saw that there was a curling going in this direction. I'll do it again so you can see it. There's a curling going in that back direction of his loading the pelvis so that he can unload in just a moment. And what you're going to see here is that as he steps forward, again, keeping as much body weight over the back side here, as he steps forward, he's going to step with that left front foot, and he's going to drive forces into the ground that are going to force back up his leg into this hip joint now. So here we go. We're going to see that he is going to apply forces into the ground that are going to transmit forces up the chain into his hip, causing this pelvis to rotate and this side to unload. And he's also causing a bend and tilting in the pelvis here. Now, as he does that, he begins to rotate the pelvis. This is where he gets the rotational force of his pelvis, is from pushing into the ground, which is driving a force through his hip. The harder he pushes down, the harder the drive is coming up. And this is not a force that is driving him backwards. This is a force that is driving in the direction of that Toyota sign right there, that is allowing rotation to happen. Since the hip joint is a ball and socket joint, it literally works in many, many degrees of action. So in this case, it's pointing right to, I guess, where that Y would be for the Toyota sign. It's going in that direction, which is causing rotation and tilt of his pelvis. Now, the rotation is important because that's what's turning this pelvis very fast. Notice, though, he's got a counter rotation going on here, a counter coiling going on that is going to uncoil. So this dance of forces is starting in the ground, going up, counter rotating at the hip, counter rotating at the torso. And because of this tilt, he's now got a spinal tilt going on. And the spinal tilt, along with flexion of the upper body, means that in two planes, he is flexed and bent. And spinal mechanics say that when you do both of those reactions at the same time, you get a rotation component that comes in. So essentially, because of the tilting that's going on, he is also now rotating the spine, counter-rotated in order to rotate. And so we're going to start by rotating applying a force here, rotating the pelvis, counter-rotating here, rotating the spine, counter-rotating the shoulder to rotate. And there are little micro internal rotations and external rotations that happen here as well with the bat. But let me just kind of get into the swing a little bit more. Here he comes now with that lateral bending, comes that rotation, the counter rotation that's leading to this rotation now. And we see the shoulders coming forward and the bat lagging, because that's going to be the final thing in the process. Is first we get the ground forces pushing up, the spinal forces turning, the shoulders turning, and now the bat turning as well. The final stage of this multi-stage rocket that is going to hit this ball with massive force. It all started though with applying a force into the ground, then in rotating internally or laterally rotating to internally rotate that backside, which causes the pelvis to rotate, because then he also applied a force in this direction. Let's kind of look at that force from a different angle. Okay, so here he is applying forces through his hip right here, right? That glute is really tight right now. And as he steps forward, he now applies a force into the ground. Applying that force into the ground is going to drive into this pelvis right here. And because this is a ball and socket joint, again, it has 360 degrees of movement, he is driving a force in this direction. Not in this direction. He's not pushing himself back towards the umpire. He's literally driving himself in this direction right here. As a result of driving himself in that direction, we got spinal tilt, pelvic tilt, and rotation. So he's unloading what he's already loaded in the back pelvis, and then causing bending and flexion, which causes rotation. The rotation was facing the umpire. Now that was counter rotated. Now he's unloading that rotation to unload the shoulder rotation to unload the bat. And that's how he's generating his power. This is the physics of the swing. It's a dance from the bottom up, or it's from up to down to up, is what it is. Notice on this pitch in particular, since the ball was kind of low and outside, Mike naturally has the audacity here to still hit that ball really, really well. But because the ball is so outside here, and it forces a little bit of extra bending and maybe a little micro disconnection here, and what that's going to cause him to do is balance his body out. And if he were to over rotate this pelvis more than he's currently doing, so that maybe the backside of the belt loop faces the pitcher, he would miss this pitch completely. So in order to square this up, he knows, and great hitters know, how to position their bodies to hit it right. And you'll notice that he's counter rotating in with his pelvis a little bit because of the low and outside nature of this pitch. His foot and his rear hip end up extending at the end to limit the rotation of the pelvis. This is commonly called a scissoring move, but essentially it's preventing the backside of the hip from over rotating so that he can flushly hit this ball the way he intended to. Anyway, this is a beautiful dance. This is the way physics works, and you can maximize your physics. It's so interesting to me to know that, you know, this process of making these decisions on how you're going to do this, you know, this is starting when the pitcher's about to let go of the ball, and it's going to take 0.4 seconds for that ball to get to the catcher. So essentially there's a lot to do. Determine the spin, what type of pitch, location, how am I going to hit it? Am I going to scissor? Am I not? That's a lot of things to do. And the more you practice your form, the more this doesn't need to be thought about. It just becomes a dance with physics to apply massive force. Then if you don't have to think about this, all you have to think about is location, how I'm going to hit this. Is it a curve? Is it a fastball, etc.? All right. Hope this helped you out. Take care.